Following EDPAD from the previous session, we will now estimate discharge using MCDPAD based on the index velocity method. First, let's briefly review the MCDPAD workflow. Just like an EDPAD, we start by entering site information and selecting discharge estimation settings. Next, measured discharge data are entered into the database along with cross-sectional area information. Then, index velocity time series data from EDPAD are imported, completing preparation for developing the index velocity equation. After developing the equation and reviewing its validity, discharge is finally estimated. By following each step carefully, the process becomes much easier. Now, let's begin. The start sheet is where information required for discharge estimation is entered. Please follow along and enter the values as demonstrated. First, enter the station information, including the code, station name, basin, river name, location, and data year. Specify whether 1 or 2 ADVM units are used. Then choose the cross-sectional area method. Enter coordinates in the coordinate field, the stage area relationship in the HA relation field, or a stage area table in the HA table field. Finally, select the water level to be used for area calculation based on stage or discharge station data. Next, set the discharge estimation method. Under the primary calculation method, select either the index velocity method or the stage discharge curve. For the secondary method, choose the index velocity method or rating curve option. Next, set the moving average, which can be defined by the time interval. The DB sheet is where measured discharge data are entered. Please input the results according to the DB format. The red section on the right indicates whether past measurements are used to develop the index velocity relation. Note that selecting whether to use the data is optional, but index velocity values must be entered. Next, the area sheet is used to enter cross-sectional area information. After selecting the station, cross-section data can be entered for up to 5 periods. There are 3 ways to input cross-sectional area data. The first is the coordinate method using distance and elevation values. The second is the HA relation, entering a 6-order polynomial equation. The third is the HA table, where stage and area values are entered in a tabular format. In practice, at KIHS, the HA table method is most commonly used. The next sheet is used to input stage and index velocity data for developing the index mean velocity relationship equation. For estimating discharge, values can be entered directly recognizing the yellow fields or imported automatically by selecting EDPAD. First, enter the water level data using 10-minute interval records. These data can be obtained from stage or discharge stations. Next, enter the index velocity data. Please input index velocity data from each ADVM at 10-minute intervals. Values may also be entered as averages by ADVM. Next, the development of index relation sheet is the most important sheet in MCDPAD for developing the index velocity relation. The sheet consists of 2 sections, left and right. Let's first look at the left section. The left section calculates values needed to develop the index velocity equation, such as cross-sectional area, residuals, and deviation ratios for each discharge measurement. First, select the index velocity sensor. Then choose the ADVM to develop the index rating, sharp 1, sharp 2, or average. Next, select the water level data to be used for discharge estimation. If only part of the measurement data is to be used, you can specify the starting measurement number. Then, load the measurement data stored in the database. When a starting number is specified, data are loaded from that point. If existing index rating values are available, they are loaded together. Now, calculate the values required for index rating, including mean velocity and deviations. If the initial index rating field is empty, be sure to enter a value before running the calculation. Once the input is completed, the measurement data can be displayed on graphs by year and by instrument. Next, let's look at the right section of the development of index relation sheet. This section is used to develop the index velocity equation and review it graphically. Let's proceed step by step. First, select the regression equation number. Then define the velocity range. Next, set the lower limit for applying the index rating. Data outside this range must be excluded from the regression analysis. For the selected regression equation, calculate the slope and intercept, and enter the maximum index velocity. The resulting index rating can be displayed on the graph. Clicking the button saves the calculation results. With the index velocity equation developed, we now move on to the discharge estimation sheet. In the discharge calculation sheet, 3 index velocity equations and 2 staged discharge curves can be developed and applied. First, enter the start and end dates for the estimation period in year-month-day order. Discharge is calculated using the average relationship from the 2 ADVM units, applying the individual equations for ADVM sharp 1 and sharp 2. Rating curve sharp 1 calculates discharge. Rating curve sharp 2 calculates discharge using the stage-discharge relationship from the discharge station. Discharge is then calculated using all 5 methods. Once all steps are completed, only the results remain. The result of discharge sheet displays the water level and discharge estimates in graphical form. By comparing discharge results from each estimation method, the final discharge data can be selected. Shall we try it together? First, select the discharge estimation method. If EDPAD is selected, EDPAD data will be used. If conditional is selected, different methods can be applied based on specified conditions. Next, enter the start and end times for the final discharge period. Then, select one boundary condition such as water level, discharge, or index velocity. After that, define the applicable range for each condition and apply the selected method to calculate the final discharge. Once the calculation is complete, check the graph based on the entered start date and period. So far, we have introduced MCDPAD, a discharge estimation program based on the index velocity method. Through this 6-session course, we hope that this has helped you understand how real-time discharge estimation technology supports field applications and water resources policy. Thank you.